All right, what I've got here is a Desmos graph, and on the left here is a unit circle, and then on the right is just a coordinate plane. So this is the vertical axis, and this is y. These are y values, and then horizontally here it's like the x-axis, but really what we have are angle values. So we can, instead of x, we can say this is theta. So what we're graphing is y with respect to theta, where theta is our independent variable, the input that we're plugging in. And what we're going to show here is the graph of the function of y equals sine theta, or f of theta equals sine theta. So if I look over here, I have A represents the central angle. So if you notice, look what happens when I change A. If I make it like 30 degrees, what we have is this 30-degree triangle kind of within the unit circle. Now we know that the sine of 30 degrees is 1/2. And look, if we're graphing, so as we increase this angle, as we rotate the angle this way, right, we're moving from left to right over here. And so that's moving from left to right, and at the same time we're plotting this whole time, we are plotting the height, right, the y value, which we know is the sine. Like if we have all these points along the edge of the unit circle, the y value is the sine. So if I'm at 60 degrees, I know that that value right there should be √3/2. Now 0.857, if you type in square root of 3 divided by 2 in your calculator, you'll get that. Okay, so I know also that the sine of 90 degrees should be 1. Okay, like that's the coordinate right there. Its coordinate is 0, 1, so that's sine. And then if I go into quadrant 2, right, if I'm getting now angles that are greater than 90 degrees, look, it jumped over, and now it's calling these reference angles over here. So a reference angle of 60 degrees in quadrant 2, 120 degrees, that's my same value back there, right, at √3/2. And so this can carry on. We can do this and continuously plot the y values, or the values of sine, the length of the opposite side of this triangle that we can draw based on the central reference angle, over time. Not over time, but over as we get larger and larger angles. And this doesn't just stop at 360 degrees or 2 pi. You can see that if we get angles larger than that, it just starts to repeat itself over and over again. That's because sine and all trigonometric functions there's several different names for them. We can call them circular functions. We can see that they're obviously related to a circle. They go round and round and round. And another word for them is periodic functions. Periodic functions are functions that repeat themselves over regular intervals. And just by looking at this, if you look at this shape, you can see that right there it starts to repeat itself. We can cut this graph right here, and then paste it over here, and we'd have the same graph again. And so the period, what we can say about that is that the period, actually something called the fundamental period of the graph of sine, the function of sine function, is 2 pi. And so you can imagine what the graph of cosine would look like. It's just a similar plot, but now it would be plotting the x values. Now also, we can have negative angle values. So if I was going the opposite direction here, I would have sine goes the opposite. It goes on and on. It's a continuous function. So what's interesting about sine is it's continuous and it's periodic. And so we can also note, right, the domain of sine. Is there any number here that I can't plug into this? Well, in this particular Desmos graph there is, but I just made it. So technically no, right? If I wanted to plug anything into here, I could. So this would keep going forever and ever and ever and ever again. There's no value of x or theta that I can't plug in. So the domain of sine would be all real numbers. And notice the range, right? The maximum y value we ever got here was 1, right? Up at these points, that's the maximum y value. The minimum y value we got was -1. And so what that tells us is that the range of sine would be everything from -1 to 1, including -1 and 1. All right, something we haven't talked about yet is how to use a calculator to come up with trig values. And I think a good way to do that would be to show how the actual calculator produces values as opposed to what comes out of the function over here that we have in Desmos. So first thing to note is that if a calculator has a button that's designated to something specifically, like it's just for that button, you can be pretty sure that whatever that thing is pretty important. So sine, cosine, and tangent have really prominent locations on this as a graphing calculator, so they're very important functions. And the way they work is, first of all, okay, we talked about two different ways to measure angles. We talked about degrees, and then we talked about radians. Now, those are very different things. If you were to put in like the input to a trig function is an angle, okay? Sine of some angle, cosine of some angle, tangent of some angle. If you put in 30 and you think it's 30 degrees, you better make sure that your calculator is interpreting it as 30 degrees. And how you can do that is by going into mode. Every calculator has some kind of button that says mode. And so what we're going to do is make sure that this is in degrees mode first. So we're going to hit mode, and then if you scroll down, you can see that it's radians and degrees. So we want to be in degrees. That's where we should be. If we hit enter, we'd be back in radians. Okay, if we hit enter back, we'll be in degrees. So we're in degrees. So if I wanted to know, for example, like what the sine of 40 degrees is, right? This is something I would need my calculator for, because 40 degrees is not one of the values that I can get off the unit circle, right? I can get 0, 30, 45, 60, 90, 120, 135, 150, 180, etc. I can get all those sixths, right? All those sixths or fourths of a full 360 degrees. 40 is not one of those. So if I want to say what's sine of 40, I hit enter, and it's 0.642. So that means if I was over here on my Desmos graph and I went over to 40 degrees, that this y value should be the same thing. It is 0.643 here. It's just rounded differently. Actually, let's go back to the calculator. What was that? So yeah, I rounded this. It would be 0.643. So you see how this lines up. Now your calculator is kind of approximating what that value is. This is a perfect value, and neither is this. These are all rounded. This would be a this would be an irrational number here, meaning it doesn't have it's not a decimal that doesn't terminate. We can evaluate normal functions. We can evaluate normal angles here too, right? Sine of 45 degrees, we know that that should be the square root of 2 over 2. And if we want to find the square root of 2 over 2, right? Ooh, that didn't work. The square root of 2 divided by 2, right? That's the same thing. So we know that that's right. We can also evaluate negative angles on here. So if we say sine of like negative 45 degrees, that's going to be the opposite, right? Because now we'd be at sine of negative 45, which is, it's not giving me fifths, 45. So we'd be right there, right? That's our negative 0.707, which is what we had there, negative 0.707. So really important is to know, like, are we evaluating, is our calculator in radians or degrees based on what we're trying to input? So if I wanted to say if I was still in degrees, right? I'm still in degrees. If I hit what's the sine of pi over 3, so pi over 3, where's pi? How come we can't put pi divided by 3, right? I know this is saying 60 degrees. I know that this should be root 3 over 2, but when I hit enter, it's not anything like that, because because pi over 3 is like basically 1. It's like 3.14 divided by 3, so it's like 1-ish. So the sine of like 1 is like, it's closer to that, right? So really that thought it was a degree, but it's not. We typed in a radian, so that means I need to change this to radians before I type in that, and that will give me my square root of 3 over 2, right? Square root of 3 divided by 2. You can see that that's that. So very important, if you're using a calculator to evaluate, to find a sine of some angle, make sure that the mode your calculator is in matches up with what kind of angle measure you're given. On Casio calculators, you can find mode up at the top. You hit mode, and then you go to, you go to you actually hit setup. You hit shift mode, that takes you to setup, and then you'll have buttons for degrees or radians. On the one I'm looking at here, which is a Casio FX115ES, 3 is degrees and 4 is radians. So it's just a little different depending on what calculator you're looking at, but make sure you've got that correct.